First of all, I would like to highlight what it says up here, that there are 3 ways to determine the enthalpy of reaction. First, the first way you could do it is by calculating using other reactions. We did this in the calorimetry lab. The second way is to calculate the heat of formation of each thing in the reaction, the reactants and the products. In this particular example, we're going to do the third way, calculate using bond energies. So what I've done in this reaction, we're to figure out what is the enthalpy, the delta H for this reaction. And it's balanced. So I drew everything out, and I'm going to look at all the bonds. So CH4 plus Cl2 gives us methylene chloride, CH3Cl plus HCl. Okay, if you look at the products and the reactants, you'll notice that not all of these bonds are broken. Only one of them is broken. So I'm just going to, this is broken. And the Cl-Cl bond is broken. You should remember that it requires energy, that's an endothermic process. Okay, over here, this is the only bond that's formed in this particular molecule. Okay, we broke this one and formed this. And then this bond, HCl, is also formed. So we have some bonds that are broken and some that are formed. And now we need to calculate the delta H, that's the enthalpy of the reaction. So that's going to equal plus the bond energy of CH. And it's just the 1. Now, where do we find this bond energy? This bond energy, you're going to find that in a table in the book. Okay, so that's where you would find this, or would be given on an exam. Okay, so that's the first bond that's broken, that required energy, plus the bond energy, I'm just abbreviating it Be, of Cl, just the 1. So this bond and this bond, and this is, both of these are broken, that's why we put a plus here. So these are broken bonds, both of them. And so this process is endothermic. Okay? Now, that's only half of it, because now we have some energy that's going to be released when these bonds are formed. So that's going to be a negative. So it takes energy to break these 2 bonds. Now there's going to be a bond energy for CCl, and that's going to be released from the system into the surroundings. And this is, and I wrote plus, that's not right, we're subtracting, so let me get rid of that. Minus, again, the bond energy of H and Cl. Again, this would be looked up in the textbook. So these are formed, and this is exo. So when we add these 2 together and subtract these, again, there's only 1 bond of each, so our coefficient is 1. When we add this all up, and again, looking on a table in the book, this is plus 411 kilojoules. And then we're going to add to that, looking in the book for ClCl, 240 kilojoules. We're going to subtract for CCl 327 kilojoules, and then we're going to subtract HCl again because it's being formed, it's exothermic, 428 kilojoules. When that is all added together, it comes out to minus 104 kilojoules. So energy is lost overall, and so that tells us that this reaction is exothermic. So we have used this third way, calculate using bond energies, looked up in book, to determine the overall change in enthalpy for the whole reaction.